Last time, we cast AdventureWorks to disk with SchemaTongs, 71 tables in JSON, every proc, every view in SQL files, all sitting on disk. That was half the job. The schema's in version control, but the database doesn't know about your edits yet. Hey folks, I'm Forge Barrett, master of the Content Forge here at SchemaSmith. Today, we close the loop, edit those metadata files, and quench the changes back to a live SQL Server with SchemaQuench. SchemaQuench is declarative. You don't write alter scripts. You don't figure out what order to drop and recreate things. You just edit the JSON to describe what you want the table to look like. And SchemaQuench diffs that against the live database and figures out the migration for you. One command. Before we run SchemaQuench, let's look at the config. This is appsettings.json. Tells SchemaQuench where to connect and where your metadata lives. Target is your SQL Server connection. Localhost port 1440. That's our Docker instance. User and password. Same credentials we used for SchemaTongs last time. Schema package path points to the metadata we cast last time. Demo output. SchemaQuench reads those JSON files, compares them to the live database, and figures out what needs to change. One more setting, verbose logging. I've turned this on for the demo so you can see every action the table quench takes, the full cascade in the log. Day to day, you'd leave this off? It's noisy. But when you're learning the tool or tracking down a problem, it's worth flipping on. Let's run SchemaQuench on our cast output and see what happens. Scripted objects go through fine. But when it hits the tables, owned by another product, table after table, same error. Here's what's going on. The demo Docker database was already quenched by the SchemaSmith demos repo with a product name of AdventureWorks. SchemaQuench stamps every table with the product name that owns it. When SchemaTongs cast this schema, it defaulted the product name to the output directory name, demo output. That's a different name, so SchemaQuench won't touch those tables. It's a safety feature. We covered product.json in a previous video, link in the description. Easy fix. Open product.json. Change the name from demo output to AdventureWorks, matching the name already stamped on the database. Save. Now SchemaQuench will recognize these tables as its own. Let's run it again. One more error. This is an idempotency problem between the function UFN leading zeros and the sales customer table. One more thing before we make our edit. SchemaTongs cast this function as a straight create or alter. That'd normally be fine, but this function has a dependency chain. Sales customer has a computed column called account number that references this function, and that computed column sits under a unique index. You can't just drop and recreate the function. SQL Server won't let you while the schema binding is in place. There are multiple ways to forge this, but the easiest fix is to drop the unique index on account number, then drop the computed column itself. Do that before the create or alter. SchemaQuench will add both back when it processes the sales customer table. It has the full definition in the JSON. Now SchemaQuench can update this function without hitting the dependency wall. Now let's make a real edit. I'll open person.address, about 19,000 rows of address data. I need the city column to hold longer values. International city names don't all fit in 30 characters. Right here. Data type nvarchar 30. I'll change that to 100. That's it. One field. But here's what SchemaQuench has to deal with. This column sits inside a 5-column compound unique index. And person address is referenced by foreign keys from other tables. Business entity address, sales order header. If you were writing this by hand, you drop the foreign keys, drop the index, alter the column, recreate the index, recreate the foreign keys, all in the right order. SchemaQuench handles that entire cascade for you. Let's run it. SchemaQuench processes scripted objects first. Schemas, functions, views, procs. Our function fix runs clean, then it hits the tables. That's where the city edit kicks in. Done. Let's grep the progress log. There's the cascade. Drop the foreign keys from business entity address and sales order header. Drop the compound index, alter the column. Then rebuild, recreate the index, recreate the foreign keys, all from one field change in the JSON. And a quick SQL check. Columns now, nvarchar 100, 19,000 rows still there, column wider, data intact. 3 things we dealt with. A product name mismatch, safety feature, easy fix. A function with a computed column dependency, real-world cast cleanup, and a column widening that cascaded through an index and 3 foreign keys. 0 migration scripts. You edit the metadata, run one command, and SchemaQuench figures out the cascade, drop order, rebuild order, all of it. Subscribe and stick around. Next time we'll cast data, capturing seed data and reference tables with DataTongs. Until then, may your quench hold fast and your data stay true.